Alright, let's go ahead and take a look at the derivative of the natural log function. Now, we said that the inverse of the exponential function is the natural log function, and we've seen in the previous sections how that those two are actually related to each other. But now we want to also go ahead and take a look at how to determine what the derivative of the natural log function is, and how to differentiate any kind of natural log composite function involving the natural log. So if we go ahead and take a look at if f of x is equal to the natural log of x, then by definition, the first derivative of the natural log of x is actually going to be just 1 over x. Okay, so let's take a look at a couple of examples here. Notice again that we have a composition of functions. So y prime is just going to be 1 over 2x plus 1 because that part needs to go into the denominator. That part needs to go into the denominator. But then we need to multiply by the derivative of what was placed in the denominator, which is 2x plus 1. So the derivative of 2x plus 1 is just 2. So we come out with the overall derivative of the natural log of 2x plus 1 to be 2 over 2x plus 1. Let's take a look at b. Y is equal to x squared times by the natural log of x. When you take a look at this situation here, you have x squared times it by the natural log of x. So you have to use the product rule. So if we go ahead and hold this one constant, that's just x squared times it by the derivative of the natural log of x. That's going to be 1 over x, plus the derivative of x squared, which is 2x, times it by the natural log of x. So if we simplify this part here, it just becomes x plus 2x natural log of x. And of course we want to factorize by saying this is x times it by the quantity 1 plus 2 natural log of x. Okay. Last one is if we go ahead and take a look at letter c. Y is equal to the natural log of x quantity squared. This right here is actually going to be the chain rule. So we have, well, the power rule and the chain rule. So we can go ahead and take a look at the power rule. So that's just going to be 2 times the natural log of x raised to the first power times it by the derivative of the natural log of x, which is 1 over x. And so what we come out with is 2 natural log of x divided by x. Okay. Now, those are some of the more direct ones. Now, there's something that we also want to consider, and these are much more difficult examples, but if you use your rules of logarithms, then these actually become quite simple. So let's just take a look at one example here, and this is y is equal to the natural log of the square root of 1 minus 2x, 1 minus 2x. Now, this could actually be a really difficult problem because of the fact that we have this complicated composite part here, which is going to be the square root of 1 minus 2x. Now, the nice things about logarithms is that you have your logarithmic rules. So, what I can do then is I can change this and say that this is the same thing as the natural log of 1 minus 2x raised to the 1/2 power. Now, using my rules of logarithms, this is equivalent to saying 1/2 times it by the natural log of 1 minus 2x. Now notice that that right there is going to be much, much simpler to differentiate. So if we differentiate that now, so d of y over d of x, this is just going to be 1/2 times it by, well, we take the derivative of that, which is 1 divided by 1 minus 2x, times it by the derivative of this, which is just going to be negative 2. So what I come out with then is if I simplify that, that's just negative 1 divided by 1 minus 2x. Okay, and there you go. Now let's go ahead and take a look at another example. Let's take a look at b. Let's say, for example, that you have y is equal to, y is equal to the natural log of, this is x plus 3 divided by x minus 1. Now, just imagine what you would have to do if you didn't use the rules of logarithms. Okay, you'd actually have to put this into the denominator, then take the quotient rule. Okay, that's going to be much more complicated than if you first use the rules of logarithms. And we know for a fact that if we just rearrange this using our rules, that this is the same thing as the natural log of x plus 3 minus the natural log of x minus 1. Now, if we go ahead and take a look at that, that makes it so much easier to differentiate that to differentiate what we're looking at before. So now we can say then that d of y over d of x is actually just going to be 1 over x plus 3 times it by the derivative of x plus 3, which is 1, minus 1 over x minus 1 times it by the derivative of x minus 1, which is again just 1. So what I'm coming out with is just 1 over x plus 3 minus 1 over x minus 1. Now, of course, if you wanted to go ahead and simplify that into one simple fraction, that's just going to be x minus 1 minus x plus 3 all divided by x plus 3 times by x minus 1. And if we wanted to simplify that even further, the final simplified form of d of y over d of x would just be equal to minus 4 divided by x plus 3 times by x minus 1. Okay, let's take a look at one more final example. And then you can go ahead and take a look at some of these on your own. Here's C. C says f of x is equal to the natural log of x times it by, this is x squared plus 1. X squared plus 1. Okay, so again, notice that in this case here, now if I wanted to go ahead and just distribute that, that wouldn't be too bad. Another way that I could do it though is if I wanted to use my rules of logarithms, this is the same thing as the natural log of x plus the natural log of x squared plus 1. So now if I take f prime of x, this is going to be 1 over x, 1 over x plus, this is going to be 1 over x squared plus 1 times it by the derivative of that, which is going to be 2x. So what I come out with then is 1 over x plus 2x divided by x squared plus 1. If I put this together, then this is going to be x squared plus 1 plus 2x times it by x divided by x times it by x squared plus 1. So what I can do then is say that the final simplified form of f prime of x is that's going to be 2x squared. So that's 3x squared plus 1 divided by x times it by x squared plus 1. Okay? And there you go. You've actually determined the derivative of this particular function, which involves a very complicated composite function involving the natural log. So there you go. Give it a shot. That's the derivative of the natural log function. See you next time. Bye.